Hello students, welcome to EPG Pathshala. In this module, we shall be discussing about wastewater characteristics of pulp and paper industry. The knowledge of wastewater characteristics is very important for the treatment of wastewater as well as for legal requirements. The pulp and paper industry is among India's oldest and core industrial sectors. The first paper mill in India was set up long back in 1812 at Srirampur in West Bengal. India is now 15th largest pulp and paper producing industry in the world, with the top positions occupied by China and United States. Annually, about 5 million people use about 400 million tons of paper and paperboard globally. So, this is one of the major industries. Paper manufacturing process has a number of steps, and from each step wastewater is generated. These steps include raw material preparation. Second very important step is pulping. There are several methods by which pulping is done, and these methods are chemical pulping method, mechanical pulping, semi-chemical pulping, pulp washing and screening. The next step is bleaching, that is the removal of color. Then next step is paper making, and final step is chemical recovery. So, these are different steps or different processes that take place during the paper making in the paper and pulp industry, and from each step wastewater is generated, and large volume of wastewater is generated from the pulp and paper industries. This table shows pollutants generated during different processes at different stages of paper making. During raw material preparation, effluent is generated from the washing of raw material. From this step, small volume of the wastewater is generated, and TSS is any total suspended solid is the major pollution load. During pulping, washing of chemically cooked pulp is carried out, and from this small volumes of the wastewater are generated, but whatever wastewater is generated, that is having high BOD, high COD, high total dissolved solid, high total suspended solids. Along with that, heat is also generated in this process. During bleaching, washing of pulp and pulp cleaning is done. During the bleaching step, large volumes of wastewater are generated, and the wastewater generated during bleaching step has high BOD, high COD, color, TDS, TSS, and toxic, mutagenic as well as carcinogenic elements in it. During stock preparation and paper making, paper cleaning takes place, filtrate from paper machinery is generated. In this step, low levels of BOD, COD, color, toxicity, metal ions and fabric fines are there in the wastewater. During chemical recovery also, some wastewater is generated, that is having low BOD and low COD and some color. So, from this table it is evident that major wastewater is generated during the bleaching process, and during other processes small volumes of the wastewater are generated, but they contain BOD and COD. So, in case of pulp and paper industry, BOD, COD, color are the major pollutant of concern. Following types of pollutants are present in the wastewater of pulp and paper industry. These are suspended solids, BOD or COD, toxicants as toxicity, then temperature, color, taste and odor. This table shows the characteristics of the effluent that are generated from different stages of paper mills. We will be mainly discussing the bleaching step. During bleaching step, 140 to 180 cubic meter per ton of paper wastewater is generated. The color of the bleaching process wastewater is dark brown. The pH of the wastewater generated during the bleaching step is 6 to 9.6. Total solids of the wastewater generated during bleaching step are 2100 to 2700 cubic meter per ton paper. Total solids during the bleaching step generated wastewater are 2100 to 2700 milligram per liter. BOD is 125 to 155 milligram per liter and COD is 550 milligram per liter to 700 milligram per liter. Dear student, please have a look on this table, and from this table you will find that wastewater generated from the paper mills is heavily loaded with color, BOD and COD, and large volumes of wastewater are generated for the production of per ton of paper. This table shows the CPCB standards for discharge of wastewater effluent from pulp and paper industry into inland surface water. There are different standards for small pulp and paper mills having capacity below 24,000 metric ton per annum and different standards for large pulp and paper mills having capacity more than 24,000 metric ton per annum. Let me discuss the standards for small pulp and paper industries. The pH of the treated wastewater should be in the range of 5.5 to 9. Suspended solids should be less than 100 milligram per liter. BOD should be less than 30 milligram per liter. Absorbable organic halogens in effluent discharge should be less than 2 kilogram per ton of paper produced. For large pulp and paper mills, the pH of treated wastewater should be in the range of 7 to 8.5, BOD less than 30 milligram per liter, COD less than 350 milligram per liter, suspended solids less than 500 milligram per liter, and absorbable organic halogens in effluent discharge 1 kilogram per ton of paper produced. There are number of approaches that can be used for the treatment of wastewater of paper and pulp industries. Primary treatment can be used, secondary treatment can be used. In secondary treatment, we can use activated sludge process, we can use aerated lagoons, even anaerobic treatment processes can also be used. Some industries use fungal treatment also. Then tertiary treatment is also required for the treatment of pulp and paper mills wastewater, and in tertiary treatment coagulation, precipitation, adsorption, chemical oxidation, membrane filtration are used. Dear students, in this module we have studied about the characteristics of the wastewater generated from different processes of a paper mill. Then we studied the Central Pollution Control Board standards for small paper mills as well as for large paper mills. In last, we saw that what methods can be used for the treatment of paper mills. Dear students, please study about these methods so you get a clear-cut idea of these technologies application in the industries. I hope you enjoyed this module. Thank you.